What's up everyone, it's Mr. Lang, and in this video I'm going to be taking you through word problems with systems of inequalities. So I'm going to do the first two questions with you, and the third one is going to be your check your understanding. So let's get started. Number one here. A company manufactures xylophones and yearbooks. That is pretty random. Anyway, the company's daily production of xylophones cannot exceed 7. And its daily production of yearbooks must be less than or equal to 10. The combined number of xylophones and yearbooks must be less than 15. Goes on, it says, if X is the number of xylophones and Y is the number of yearbooks, graph on the accompanying set of axes the region that contains the number of xylophones and yearbooks the company can manufacture daily. So it tells us X is xylophones, Y is the number of yearbooks, and we got to kind of get as many equation or inequalities out of this as we can. So the first one I see is the xylophones cannot exceed 7. So it could be 7, but you can't go any more. So X is the number of xylophones. It can't exceed 7, so it's got to be less than or equal to 7, and that's my first inequality. The next one is yearbooks must be less than or equal to 10. Well, Y is the yearbooks. Here's our 10, and it must be less than or equal to 10. Normally we're used to 2 inequalities and graphing them, but a lot of times with these word problems you get 3, and in this case we do. And it says the combined number of xylophones and yearbooks, that would be X plus Y, must be less than 15. So these are the 3 inequalities we got to graph, and we're going to do that. Luckily, none of them look hard. So this would be my xylophones. And over here is my yearbooks. Okay, X is less than or equal to 7. That's going to be a solid line. And it's a vertical line because it's X. So I'm just going to count to the right 7. 1, 2, 3, 4, 5, 6, 7. And draw my line. And I'm just going to fill up the whole graph. I'm going to label that X equals 7. Cool. Y is less than 10. Well, that's a horizontal line. So I'm going to count up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And go across here and fill up my whole graph that way and label it. This is Y equals 10. The last one I've got to put into Y equals mx plus b form in order to graph, so I'm going to subtract x from both sides. And we get Y is less than negative x plus 15. This would have a slope of negative 1 or negative 1 over 1. And my y-intercept is 15. So listen, I've got to graph this one. If this is 10, this would be 11, 12, 13, 14, 15 as my b, and a negative 1 over 1. So I'm just going to go down like this. And that is probably good. And this is a dashed line. So let me do this. And draw my line like this. Notice I'm not doing arrowheads here because we're really dealing only in the first quadrant. So it wouldn't really go on forever. So I'm going to label this Y equals negative x plus 15. Alright, so I got everything labeled. Now check this out. I'm going to do something a little bit different with these to keep our graphs neater. I'm going to go right to my shading. Now listen, we've got to be to the left of the x line here, x equals 7, so that would be this way. I've got to be down from the 10. That would be down here this way. I could shade all this in, sure. And then I've got to be, this is less than this line, so it's here's my line here, and it's got to be less than, so it would be this way. So the area that makes all that up is this rectangle minus the little fold right there. This would be my solution area. Alright, if you want to draw in all the shading ones like we've done before, great, you can do that, but this is just such a neater way to do it if you can see it. Now if I would say even if you get one of these wrong by trying to shortcut it, then just go back to the old way. But I'm going to draw my solution area here. So any XY point here would represent the number of xylophones and yearbooks that would be okay to manufacture. Alright, let's get to number 2. Number 2. Alright, so Mary babysits $4 an hour for $4 an hour. She also works as a tutor for $7 per hour. She is only allowed to work 13 hours per week, and she wants to make at least $63. Very specific here. Alright, so part A, it says, write a system of inequalities to represent the situation. Use X for babysitting and Y for hours tutoring. So I'm going to start with the 13 hours per week. Well, she's got these 2 jobs. Then if I combine the hours, the X plus the Y, she can work only 13. She could work 13, but no more than that, so it's going to be less than or equal to. Now I got to deal with this $63. She makes $4 per hour for babysitting. If you add that to the $7 per hour tutoring, she wants to make at least 63. So that means 63 would be good, but more than that would be better. So it's going to be greater than or equal to. And now what we've got to do is graph this on the axes below. So what I'm going to do is pause the video here, do it myself. You can handle this too. You just got to put it in y equals mx plus b form first, rearrange it, and you're good to go. And so pause the video here, do your own work, and then we'll compare our answers. Alright, so let's see how you did here. What I did is I rearranged the top one, x plus y is less than or equal to 13 over here. And I ended up getting y is less than or equal to negative x plus 13. I got a slope of negative 1 over 1 and a y-intercept of 13. Over on the left, I did the second one, and a couple steps later I got y is greater than or equal to negative 4/7 x plus 9. So the slope is negative 4/7 and the b is 9. Both of these are going to be solid lines. So let's see what the graph looks like. Both solid lines. I've labeled them both with the equal signs. It's going to be above this line and below this line. So you could have done the whole shading. You got a pretty messy graph. So if you can just kind of shade the part where your solution area is, then that's good. So it should just be this little sliver here. Alright, so let's get on to the last part here, and it says for C, check a point in your solution area. So I can pick any point in here, so I'm going to choose the point 1, and then I'm going to go up to 10 here. This is right in the middle of it. So the point 110 is a great point to check, where the 1 is my x and the y is 10. So let's do this. The first one would be x plus y is less than or equal to 13. So that would be 1 plus 10 is less than or equal to 13. That's 11 is less than or equal to 13, and that checks. The second one, 4x plus 7y is greater than or equal to 63. So this would be 4 times 1 plus 7 times 10. And I can already see this is going to work. 7 times 10 is 70, but we'll go through the formality of this. This would be 4 plus 70 is greater than or equal to 63. So 74 is greater than or equal to 63, and that is of course true as well. So 110 checks. And then the second part of this, though, is what does that point represent in terms of this scenario? Well, if the x is 1 and the y is 10, the x, again, if I kind of go back, is the hours babysitting, and the y is the hours tutoring. So what this solution 110 means is that 1 hour babysitting and 10 hours, that looks like a 20. I'm going to read. And 10 hours tutoring that's what that 110 represents, and that means that that would be an acceptable solution. Alright, so your SIA question is the third question on the sheet. There's nothing to do online, so just bring your sheet with you to class. Thanks for listening.